所以到底为什么 AI 的这一些股票会涨呢？那么其实好多年我们都在讲 AI 了，去年的 AI 跟今年的 AI 有什么不一样？我们现在来看仔细了。这一次的电脑展呢，辉达执行长黄仁勋他讲的就是同一个重点，叫 AI 代理。什么是 AI 代理？简单来说，就是现在的 AI， 它只能够回答你的问题。但是如果是 AI 代理的话，它不只是可以回答你，还可以帮你完成任务，就像是你的 Jarvis， 像是你的贴身助理一样。这当然是近10几年来、几十年来的重大发明。所以呢，就在今天，当辉达全球媒体问答的时候，还罕见的开放录影，甚至邀请旁边这一位就是联发科执行长蔡力行，他们强调的就是所谓的 AI 代理将成为未来10年最重要的运算革命。
Great, Jerry, don't be still friends. Always. I don't know. Go with chilling. Yeah.
辉达执行长黄仁勋举办全球媒体问答，联发科执行长蔡力行惊喜现身，两人互开玩笑问候，大谈开发 RTX Spark 秘辛，更揭露双方合作打造的 ARM 架构 AI PC 蓝图。
N1X has N2X and it's got N3X already planned. And N1X is called N1X because N1X has a smaller version called N1. And so we're going to expand our family.
除了新平台规划，黄仁勋也大谈 AI PC 未来发展，强调 AI 代理将成为未来10年里最重要的运算革命。未来的 AI 不只能够理解，还可以使用工具来完成任务，就像是个数位机器人。举例来说，如果你今天要规划韩国3天2夜的行程，一般的 AI 只会列给你一堆景点，告诉你哪一天可以去哪里。但是 AI 代理还会主动帮你比价，在授权内自行刷卡，帮你订机票、订饭店，甚至订景点门票。完成订单后，还会把电子机票、确认代码等通通整理好传给你，就像是你的个人秘书。
So it's very likely that we prefer that they just use the tools we created. So agents are going to not replace tools. Agents are going to use tools.
除此之外，黄仁勋也把 AI 代理应用延伸到更广泛的区域，像是卫星、基地台、人形机器人跟自驾车等等，未来也都拥有 AI 代理能力，能够快速完成工作。
The agent is going to be so valuable to you. You want it to be sitting in a nice box, sitting in a nice computer, secure, performant, something you could carry with you, something you would use for a long period of time, not just, right, replaced every year. I might have this system in my house for 5-10 years.
要完成这些愿景，当然少不了台湾的技术。黄仁勋笑说，最好的投资就是花钱。辉达已经是台湾 AI 供应链的最大买家，也强调台湾在全球的科技指导核心地位难以撼动。下一波 AI 浪潮将会继续改变世界。东森财经新闻台北报道。
所以，当我们要执行 AI 代理的时候，你要透过什么样子的东西可以让 AI 来帮你做事情呢？答案很简单，就是 PC 你的电脑。所以今天呢是电脑展的第一天，辉达执行长黄仁勋就忙着到处站台，所以你只要跟着他走，你就知道了现在能赚钱的黄金趋势在哪里。尤其呢，这次 CUDA X 执行长这个辉达执行长黄仁勋，他告诉大家，他要进军所谓的 AI PC。所以今天他逛的台场就是这些电脑大厂、PC 大厂，你想得到吗？台湾的几家像宏基啦、华硕啦、技嘉，甚至 AI 时代非常重要的 CPO， 他也没落下来。第一场的站台演讲选的就是光通讯大厂迈威尔。
AI 教父黄仁勋一来，马上挤爆 CUDA X 必做清单就是逛展。这次开展第一天，先和华硕董事长施崇棠笑说合作30年，现在重点放在 PC 进到代理 AI， 来到宏基，现场气氛也超嗨。踩到的点都点石成金，也来到云达、联发科、技嘉等展位，不难看出 AI 真的是正式从云端实现落地进到终端。过去从没在开展首日就逛 PC 品牌厂，这次一定要来挺好友，印证黄仁勋所说的 AI 已经迎来实用 AI 新时代。
Demand is so great because agentic AI has arrived. AI is useful now. The amount of compute used for AI has grown 100, 1,000, 100,000 times. Demand growth is driving ultimately chip demand and NVIDIA compute demand.
把愿景变现实，黄仁勋说，辉达在投入每个市场前，都是先想到如何替产业带来贡献。除了近期围绕的话题，代理 AI、光通讯、CPU 的发展也是重要关键。
And so you use optics wherever you must.
you use copper wherever you can. And so I think that intersection is going to continue for a long time. Here's the bottom line is, in the next 5-10 years, we're going to use a ton of copper, and we're going to use tons and tons of optics.
话作也跟当黄仁勋牵起整个 AI 供应链，就像超人般忙站台，也来到安谋执行长主题演讲，依旧扣着主轴代理 AI。安谋也强调，已经在台湾打造2500亿颗晶片，再到 AI、CPU、伺服器到 AI 基建，都在台湾制造。看台湾就是全球运算核心，小小的岛却有大大能量。东森财经新闻毛中颖、陈浩廷、张君台北从报道。
We talked about several things yesterday. The most important thing we talked about, okay, if there's one takeaway, is that there's a new computing pattern. The architecture of an application. The architecture of an application, and this application is called an agent. The architecture of that is consistent throughout. It's called a harness. There are many different types of harnesses, but they're largely similar. They orchestrate the thinking process. The GPU still has to do thinking step by step by step. So it has to understand the context, the situation. It has to understand the intent, the prompt. And it has to reason about it, break down problems step by step, and think. And so the CPU routes the computing thinking from GPU to CPU, memory to the GPU, so on and so forth. Okay? And that CPU sits inside the Vera Rubin rack, or that CPU sits inside the Grace Blackwell rack. Maybe another CPU has to move long-term memory to working memory. Maybe it has to activate a tool, launch a small tool, maybe use a browser, execute code, write code, maybe even turn on Adobe Photoshop. Okay? And so the CPUs would have to be used for that. But overall, the harness allows the AI to think and reason, use tools, work with memory. But that computing pattern is consistent, whether it's in the cloud, in a robotic system like a self-driving car, in a robot itself, and of course, we invented a brand new type of robotics computer, a brand new type of agent computer, and we call that RTX Spark.
We have so much to tell you, and I have so many partners to thank. It is incredible how large our ecosystem in Taiwan has become. Most of the time, when people think about ecosystem, they think about our software stack. They think about the developer ecosystem above the computing systems that NVIDIA builds. But NVIDIA's ecosystem spans all the way upstream to all of our supply chain here in Taiwan, where it all begins, and downstream all the way to data centers and eventually to end users. Today, we're going to talk about almost all of the ecosystem. There's so many people to thank. I love my ecosystem here. I mean, there are so many companies here, and some of my favorite ecosystem partners. So many. Taiwan's rich ecosystem, the richest ecosystem, the world's best supply chain ecosystem. Unbelievable. Well, thank you all for being here. And this year, our businesses together are growing incredibly. In fact, somebody told me last night that the annual GDP of Taiwan is going to grow almost 10%. Unbelievable. Well, we have a lot to talk about. Let's get going. 2 years ago, when I was here, I started to talk to you about how AI has moved from generative AI and the other waves of AIs that are coming. The next wave of AI was agentic AI. And today, we can say that agentic AI has arrived, that useful AI has arrived. Now, what does this mean? This is GitHub. This is, of course, one of the first applications of agentic AI is software coding, one of the most valuable professions. Incredibly large ecosystem, 30 million, 40 million professional software developers, probably another couple of hundred who are students and enthusiasts and so on and so forth. But say 30, 40 million software developers in the world code for a living. And this represents most of them. This is GitHub. The pull request is when they download software, they modify it, and commit is when they push it back up. Okay, and so if you could look at this, in 2023, the number of commits was 300 million. 2024, 400 million. 2025, 500 million commits. In the first few months of 2026, it has nearly tripled. Now, what does that mean? 30 million software developers representing about $3 trillion worth of GDP, producing that's what they're paid, $3 trillion worth of salaries per year, which is generating economic growth for the rest of the industries. Say $100 trillion of the world's industries is generated by $3 billion worth of salary. That $3 trillion worth of salary is now producing nearly 3 times as much output. It's effectively a $9 trillion productivity from $3 trillion of salaries. Does that make any sense? The difference is absolutely extraordinary. This is the potential. This is the promise of AI. The number of engineers, software engineers, is actually increasing. People talk about AI reducing jobs. Complete nonsense. It's causing more software engineers to be hired, and the reason for that is very simple. If you can hire a software engineer and you could generate $9 trillion worth of productive work, why wouldn't you want to hire more software engineers? If that line was flat, then obviously people will hire fewer software engineers. But because the output is so incredible, people want to hire more software engineers. This is going to show up in our economy somehow soon. And so the first thing is useful AI has arrived. Now, what does that mean from the industry's perspective? From the industry's perspective, that means that tokens are now in extraordinary demand. Because if you could do this, you're going to want to produce more of it. And because tokens are now profitable units, tokens are now profitable units of revenues. Because it is now profitable, the AI companies want to build a lot more tokens, generate a lot more tokens, build more AI factories, which is the reason why compute demand here in Taiwan has skyrocketed. It is precisely the reason why all of you are so busy and your businesses are doing so well. In fact, that looks like some of your stock price. The compute pattern has changed. Everything has changed. So the first idea is that useful AI has arrived. AI is now a profit generator. AI is now a GDP generator. Behind it is a whole new kind of computing pattern. Not just a large language model, but an agent. Today, almost everything we're going to talk about is going to be based on this. So let me take a quick moment and show you what I'm talking about. This is an agent. It's an agent application. In the old days, this would be application, this would be code, and this would be operating system. Application, code running inside an application, inside an operating system. Today, it is agent, which consists of a large language model or many sitting inside a harness, and that harness helps it, orchestrates it to do productive work. This is the input. When that input comes, It has to understand, observe, reason, act, use tools. That tool could be a spreadsheet, web browser, a data processing engine, database engine, for example. This is orchestrated, this harness orchestrate this routing of information every single time it touches either processing the context, understanding what is happening, reasoning about what to do, coming up with a plan that it acts on. That orchestration path is orchestrated by some software. And so this is fundamentally an agent. It deals with short-term memory, called working memory, long-term memory, just like we do, we have long-term memory. And so the memory management system is incredibly important. This entire system is called an agent. The large language model is used to do the thinking, and the harness connects everything together, just like an operating system, okay? And so this is the new computing model, and this is what an agent. It can do incredible things. This is the big breakthrough. The simultaneous convergence of large language models that are now able to do a really good job thinking, reasoning, planning, using tools, and the fact that we have now these harnesses that manages memory, the orchestration, uses tools, we can now do amazing things. Let me give you some example. This is a prompt. This is the prompt. This is the code that is generated, and this comes out. This is the input. This is the input, and that's the output. What do you guys think? It's pretty amazing, right? We use Claude Code here, but CUDA X does an incredible job as well. Here's another example. This is the input. Create a GIF, NVIDIA green dots on black scatter, form Taiwan 101 building, morph to GTC Taipei 2026, morph to NVIDIA I logo, then scatter and repeat, right? So you saw that. That was the prompt. Here's the next one. I lost my remote control battery clip. It looks like this. Create a CAD file. It uses a tool, create a CAD file, ready for 3D printing to create a new one. Make sense? This is now the new computing pattern. Whereas we used to launch an application, click and type, we now replace that with explaining to the AI what we want, our intent, and the AI generates the code or uses tools and produce the necessary output. This is how computers are going to work in the future. This is agentic AI. For 2 years, we've been building towards this, and now it has arrived. Now, one of the big breakthroughs, of course, is tool use. A lot of people have said, you know, Jensen, AI is coming, agentic AI is coming, therefore all of the software companies are going to go out of business. I said it's exactly the opposite. Because there are going to be so many agents, the world is no longer limited by the number of people. Therefore, those agents are going to use more tools than ever. This is actually an incredible time to be a software company. But the software has to be presented to the agent in a way that the agent can use it. This is a big breakthrough. And in fact, what we have done, as you know, what NVIDIA's treasure is all of our CUDA libraries. I call them CUDA X libraries. This is NVIDIA's treasure. Today, we're able to now present these CUDA X libraries to agents who can use it much more effectively than even humans. And so this is a wonderful time for CUDA X libraries. Let's take a look. 20 years ago, we built CUDA, a single architecture for accelerated computing. We reinvented computing. 1,000 CUDA X libraries help developers make breakthroughs in every field of science.